So let's look and see what derivatives actually mean in the real world and of course the business world. So let's look at marginal analysis. So in business, what do we refer to as marginal? Well, that's change. So in other words, marginal refers to the next additional unit, product, person, or whatever you're associating the term with. So if we say marginal profit, how much more would we make by selling one more additional unit? And you see, of course, in the business world, the most used terms with marginal would be with cost, marginal cost, and marginal revenue, as well as my last example of marginal profit. Business certainly place a lot of importance on these types of terms because not only do they want to maximize their profit and minimize costs, but they want to be efficient. So in other words, if your marginal cost is increasing while your marginal revenue is decreasing, that's not a very good thing, right? So it wouldn't make sense to just continue to make the product. And so by businesses looking at these margins, it not only gives them just the big picture, but they can also see what would happen in the short run. Again, making one more item. So again, in business, we refer to marginal as change. Well, a rate of change is a slope. Change of Y over the change in X, the change in dollars over the change in time, change in dollars over the change per unit. And this is what the definition of a derivative is. So this works out perfectly for what you're learning because you're learning derivatives, and this allows us to be able to find these margins. So if we want to look at marginal cost, well, C of X would be the cost as a function of X producing X items. So marginal, if this is a rate, the change in cost over the change in quantity, then that's simply, you find it by taking the derivative. So if you have cost and you need marginal cost, then you take the derivative and it gives the instantaneous rate of change, which is our definition of the derivative, of total cost with respect to the number of items produced. Same thing with marginal revenue would be the change in revenue over the change in our quantity. So we find our revenue function and we take the derivative of it. How do you find profit? You take revenue minus cost. So how would you find marginal profit? Right? You would take the derivative of revenue, the derivative of cost, and those would be the two that you would subtract. So let's look at an example of a company that's manufacturing fuel tanks for cars. The total weekly cost in dollars is given by this cost function. I want to find the marginal cost. Well, I take the derivative. So how do I take the derivative? We just learned from the last lecture that we can do shortcuts. The derivative of 10,000 would be 0 because that's a constant. The derivative of 90x would be 90. And then the derivative of minus 0.05x squared, I keep my negative, I bring the 2 down. 2 times 0.05 is 0.10. And I subtracted 1 from my exponent, so that's why this becomes x now. And so now I could do something with this, like use the marginal cost function for a production level of 500 tanks per week. So I got my marginal cost, I plug in 500 and I get $40. Well, what that means is at a production level of 500 tanks per week, the total production costs are increasing, because that's positive, at the rate of $40 per tank. Or in other words, that's how much it would cost to produce one more tank. What if now I have still this fuel tank cost function? I want to find the exact cost of producing the 501st item. Well, I could find the cost of a single item by using this difference. In other words, just plug in my cost function, 501, and then 500, and subtract the 2. So I go back to my original function here, and I plug in 501, and I plug in 500, And notice I get something really, really close to, I said it would cost $40 more to make one more item. And so then you might say, well, then why do I need derivatives? Remember that when you're plugging this into the cost function, you're actually getting an approximation. Okay, so remember, this is my average rate of change, where with your derivative, you're getting an exact, your instantaneous rate of change, where I can see what's happening because at different production levels, this slope, the derivative, is going to change. And so I'm going to get different values. And this is important that also notice your cost of producing another tank is starting to decrease. That slope, if you look at these lines, your tangent line, that slope is starting to get smaller. Notice here 70 to 40, because eventually it's not going to pay off to just keep making these tanks. Let's look at a company that is manufacturing these headphones. So after suitable test marketing, the research department gives you this price demand. So you know X is your demand, P is your price. Typically, you see this is solved for P. In other words, what we like to say is our dependent variable, our price, depends on our demand, our independent variable. Well, no problem. We're good with algebra, right? We can solve this for P. So all I did was I subtracted the 10,000 from both sides, and then I divided by this negative 1,000. So I just solved this equation for P, which again gives me my price as a function of my demand, which we kind of like. Well, what is the domain of this price demand function? Remember, a domain is the good values of X. Well, you might say, well, you can plug in any X, but the problem is you have to be careful with real world stuff that my price and demand should both be positive, but I'm not just going to make 5 million headphones, so I base it off of this equation. If it has to be positive, I set my price demand equation greater than or equal to 0. I solve this by subtracting 10 on both sides, and then I divide by, you remember when you divide by a negative, you have to flip the sign. So this basically says I need to make between, probably not 0, because I would like to, make at least one headphone, but from 0 to 10,000, and this keeps my domain within my price function. Well, our financial department says, hey, we come up with a cost function where the 7,000 are our fixed cost, the 2x are our variable cost. So what we want to do now is we want to actually look at marginal cost and see what it would mean. Well, here's cost. How do you find marginal cost? You take the derivative. The derivative of 7,000 is 0. The derivative of 2x would just be 2. So what this means, it would cost an additional $2 to produce one more headphone. Notice this is at any production level because we lost all of our variables here. Okay, so again, the interpretation is very important that you get this down on these. Well, hopefully you know where we're going to go with this. We want to make money, right? So we want to look at the revenue and also find its domain. How do you find revenue? You take the number of headphone sets sold times the price per headphone. Well, my number of headphones, that's my X. We already, and this you can see now why we like to solve this for P. We have our price demand function I can plug in here, and that gives me my revenue. Now your domain doesn't change. So your domain stays the same from what you found with your price. Well, let's keep going and let's find marginal revenue. So how do you take the derivative? The derivative of 10x would just be 10. The derivative of this piece, I bring the 2 down and I subtract 1. So that this gives me a revenue, my marginal revenue. So now I can look at different values such as let's look at these different production levels, 2,000, 5,000, and 7,000. So I take my revenue function, I plug in 2,000, I plug in 5,000, and I plug in 7,000. Okay, again, this is marginal revenue. So what do you think these numbers mean? I mean, think about that a minute before you just continue listening and say, well, I know you're going to tell me, Cindy, right? Think about, what does 6 mean, and what's the difference between positive and negative and a 0? Well, I always like when I look at derivatives. Remember I told you I like that notation, the dy dx, because that helps me figure out what this means. My marginal revenue is my change in my dollar over the change in production level. So this says producing 2,000 headphones, revenue increases, because this is positive, by $6 per headphone set. Well, the 0 would basically say producing 5,000 headphones is not really going to make a change in revenue. And then this is the point here that says, well, if you just keep producing these headphones, your revenue starts to decrease. And think about why that might happen. Maybe you got to hire more people. You got to set up machines more. And so definitely this wouldn't be good to do. Well, let's look at the graph of the cost function and the revenue function together and look at the intersection points. So we can see this was our revenue. We can definitely see it's x squared, it's negative, so that's why it looks like that. Our cost is linear, okay, and we can look at these break-even points, which we've talked about already, that are very important. If I want to find those, I want to find where revenue equals cost. I have my revenue function, I have my cost function. How do we find where they're equal? We set them equal and we solve for x. Now, you guys have all been through algebra and you could use the quadratic formula, but why not work smarter? Find an online calculator. This is just one I use. Okay, you can use any one you like to be able to notice that this is your A, this is your B, this is your C. Remember, when you solve a quadratic, you set everything equal to 0. And so then you plug in your A, don't forget that negative, you plug in your B, you plug in your C, and this gives you your solutions. So this is your break-even points are at 7,000 and 1,000. So that's where you're breaking even. So I could go back and I could plug those values in and of course look at the graph once again, because that would make sense to plot these to see that's these points here. You can see that this is at 1,000, this one's at 7,000, and then it gives me, which is nice to go to your boss and say at this 1,000 and 7,000 is going to be where you would be breaking even. Well, your boss says that's all nice. I've seen a price demand, I've seen a cost, I've seen revenue, but show me the money, right? Let's figure out what that profit is. So you know how to find profit. You take revenue minus cost. So here's my revenue minus my cost. Please don't forget to stick this in parentheses or distribute that negative. Okay, don't forget that. And then I can look at the graph of just profit, and where it's hitting the x-axis is actually my break-even points. So if I'm above, I'm making money. If I'm below, I'm losing money. Which you can also see that in our revenue and cost graph, that you can see here is where our profit is above these break-even points. Well, let's look at the marginal profit for these different levels of headphones. How do you find marginal profit? You take the profit function that we just found and you take the derivative. You got these derivatives down now, right? You're practicing. Practice, practice, practice. So let's take marginal profit and plug in 1,000, 4,000, and 6,000. So there's 1,000, 4,000, and 6,000. And we can see the same things going on here. Our change in profit over the change in production. 1,000 output level, profit is increased if production is increased. 4,000 small change, Probably not, very good thing to do. And then of course 6,000, your profit starts to decrease. Also in this section, it talks about how to find an average cost, average revenue, average profit. I mean, you know how to find an average, right? You add something up and you divide by the number of those somethings, like grades. So I might want to know the cost per unit or revenue per unit and so on. So I can use these formulas, average cost, so that little line over it. If you've had statistics, you've probably seen this before as an average. But that little line means average cost. Well, you take the total cost and you divide by the number of units. Marginal average cost then would be the derivative of average cost. And then the same for revenue and profit. So a small machine shop manufactures drill bits used in the petroleum industry. The manager estimates that the total daily cost in dollars producing X bits is this cost function. Find the average cost and find the marginal average cost. Well, average cost would be take this cost function and divide by the number of units, which is X. And I can make this look a little better. All I did was I divided each individual term. Remember, you can only do this if you do it to every single term. So I divided 1,000 by X, you can see that there. I divided 25 over X by X, so the X is canceled. And then I divided this minus 0.1X squared over X, so this X cancels one of those out. But please remember, you can only do that if you do it to every single one of them. And so now I can look at my marginal average cost by taking the derivative of my cost, and this is why I split those up. So I can now look at each one of these individually, and so I would bring this X to the top, which would make it X to the negative 1, and that's how I end up getting this for my derivative. The 25 is a constant, it goes away, and the derivative of minus 0.1x would be minus 0.1, and then I bring my negative exponent to the bottom. So this would be my marginal average cost. Well, let's do something with this stuff. Let's plug in 10. Okay, so producing 10 bits and see what this means. So if I plug into my average cost, this tells me at a production level of 10 drill bits per day, because this is given to me up here, the average cost of producing a bit is $124. If I look at my marginal, this says the cost is decreasing at a rate of $10.10 per bit. If we want to estimate the average cost per bit at a production level of 11 bits, well, if the production level is increased by 1 bit, in other words, from 10, which is what we plugged in here, to 11, we're saying that it's decreasing by this 1010. So the average cost per bit at a production level of 11 would be what it was at 10 and then the rate that it's decreasing.